Good morning, everyone. My name is Akshar. Why I've started this course? It's very easy course. I mean, you can search any concepts. Just like you could take example of what I'm going to teach you today. So, you might have heard of that if you want to check whether a number is divisible by 4. So, you just have to check last two digits, and you just know the trick. But did you get to know what's running behind that? I mean, from where it came. So just to cross that hurdle, I started this course, and I have started this channel, Project Pivot. Okay. Today I'm going to start with number system. It's a very easy topic, and I will teach you the concept of divisibility of powers of 2. Okay, so let me start. Divisibility of powers of 2. So what does it mean? I mean, you might have heard of divisibility rule of. Okay, I forgot to write rule. So you might have heard of divisibility rule of 2, divisibility rule of 4. So you know that if you are given a number, and if you want to check if it's divisible by 2, you just have to check the last digit. If it's divisible by 2, then the whole number is divisible by 2. Okay, let's take an example of very simple number 7. Okay, so I'm asking you, is it divisible by 2? You will just say no. It's very simple. And if I add a 2 here, it's still not divisible by 2 because you just check the last digit. And if it's not divisible by 2, the whole number is not divisible by 2. Okay. And about 4, how do you check? I'm again giving a very simple example, 28. So you know that it's divisible by 4. Okay. If I add any number like 6, again it's divisible by 4 because you're checking last two digits of a number. So what did we conclude? To check if a number is divisible by 4, you just check its last two digits. If the last two digits are divisible by 4, then the whole number is divisible by 4. And for 2, the last number was 7. So it's not divisible by 2. The whole number is not divisible by 2. So why are we checking last two digits? Okay. And what's the meaning of divisibility rule of powers of 2? It means that today I'm going to tell you divisibility rule of 2, 4, 8, 16, 32, and up till infinity. Okay, let's start. Suppose you are given a number A, B, C. Okay. Now we very well know that you can just open it up by writing C plus 10 times B plus 10 times 100 times A. Okay. You can write like this. Okay. Just take an example of 123. So you can write 123 like 3 plus 2 times 10 plus 100 times 1. You can write it like that. And it's 3 plus 20 plus 100. 3 plus 20 plus 100, and that's equal to 123. Okay, so you can write a number ABC like C plus 10 B plus 100. Okay, I don't think that you should have any doubts up till here because concepts are very easy. 10B plus 100A. Okay, now I'm gonna ask you a question. If I'm dividing ABC by say any number X, any number X. If it's divisible by X, if ABC is divisible by X, So should it not be divisible by this whole term? Right? Can you write this whole term like c by x plus 10b by x plus 100a by x? You can write that. And what does it mean? That it should be divisible by c should be divisible by x, 10b must be divisible by x, and 100a must be divisible by x for the whole number to be divisible by x. Isn't it true? Because if any number is not divisible by x, if any of these three terms is not divisible by x, then for some term the answer will be in decimal. Okay, because if c is not divisible by x, it will be something like you will get some decimal value, then you won't get integer value. So every term should be divisible by x. Okay. Okay, I think everything's going easy up till now. Now I'm asking you one question. If I put 2 instead of x, if I put 2 instead of x, you can write it like, wait a bit. Yeah, sorry, it was not visible. Yeah, if you put x as 2, you can write it like c by 2 plus 10b by 2 plus 100a by 2. Okay, now if you want ABC to be divisible by 2, which term among these three should be divisible by 2? Which? Don't you think that it should be C? Because 10b is of course divisible by 2. It's 5 times B. 100A is also divisible by 2. It's 50 times A. All that is stopping for this whole number to be divisible by 2 is C. So I think C is the only factor that's stopping us, to reach that goal. I mean, you could say it anything. So C must be divisible by 2. C must be divisible by 2. Okay. And what was C? I think the last number. I think C was the last number. So to check the divisibility of 2, you should just check the last number. I just proved that. Okay. Now let's talk about 4. I just want to check if a number is divisible by 4 or not. Again, you can write it like C plus 10 times B plus 100 times A. You can write it like that. Okay. Now, for all those terms to be divisible by 4, which term should be divisible by 4? As you can see, 100 is divisible by 4. We know that because 100 by 4 it's 25. So this term will be 25A. This term will be 25A. We don't have any issue. Okay. Uh, but we have an issue here because 10 is not divisible by 4. It's 2.5. Then B must be something that makes 10 be divisible by 4. And again, C must be something that makes it divisible by 4. So can I say that C plus 10 times B must be divisible by 4? And isn't it the last two digit? Because the third digit is it's A. So isn't it the last two digit? I think you shouldn't have any issue up till now. Let me go to, let me first increase the number of digits because we are now talking about 8. Can you write it like D plus 10 times C plus 100 times B plus 1000 times A? Now, which of these term is 110% divisible by 8? Of course, 1000. 1000 by 8, it's 125. But the last three digits, 100b plus 10c plus d, we don't know that it's divisible by 8 or not. So for the whole number to be divisible by 8, only these three numbers, last three numbers should be divisible by 8. We don't want this because we know that it's of course divisible by 8. So did you notice one thing? 10 is divisible by 2. Okay. So 10 is the second digit. Okay. First digit, let me give you an example. A, B. Okay. B is the first digit. We can write this number as B plus 10 times A. Okay. So B plus 10A. Uh, so 10 is divisible by 2. So you don't check the second term. You just check the first term. 100 is not divisible by 8, but it's divisible by 4. Okay. So for 4, you don't check the third term. You just check second and first term. 1000 is divisible by 8. Okay. And 1000 is the fourth digit. So you don't check the fourth digit because you know that it's divisible by 8. So you just check the last three digits like hundreds, tens, and ones. Okay. For 16, 2, 3, 4. This is divisible by 16. This is divisible by 16. So you don't need to check that. You just need to check the numbers which are at thousands place, hundreds place, tens place, and ones place. So for A, B, C, D, E, which is at 10,000s place. This is at ones, tens, hundreds, thousand, and 10,000. So do you need to check that? It's already divisible by 16. You don't need to check that. So you just need to check for B, C, D, E. Okay. So for 2 to the power 1, you just need to check the last digit. We just noticed that. For 2 to the power 2, you just need to check for last. Okay, so you were not able to see that. Sorry, I'm literally sorry. I can explain it once again. Yeah. So we were here. We know that at tens place, it's the second digit. Okay. So for 2, 10 is divisible by 2, but not 4. So whenever you check divisibility for 2, you just check the last digit because you already know that in the tens place, you will get any number. Okay. It's divisible by 2. If it's 6, 7, 8, 9, it's any number, but it's divisible by 2. Okay. So we just need to check the last digit. But 100, now we're talking about the hundreds place. So 100th place, it's divisible by 4. Okay. So for 4, you need to check the 10th place and ones place. Okay. For 4, you need to check 10th place and one first place. Okay. It's for 4. Now for 8, we know that 1000 is divisible by 8. We know that. So why would you like to, means why would you check for the thousands place? And the thousands place is the fourth digit. If you take A, B, C, D, so this is the ones place, this is the tenth place, hundredth place, and thousandth place. So for 8, you won't check that because you very well know that it's divisible by 8. It's going to be divisible by 8. So you will just check last three digits. And for 16, 16,000 is not divisible by 16, but 10,000 is. Okay, so you won't check numbers from 10,000 then 1 lakh. You will stop whenever you see the 10,000s place, and you will check all those numbers before that. Before that, it means like thousands, hundreds, tens, and ones. Okay, so you will check all those four digits to check for divisibility for 16. Okay, so for 2 to the power 1, you just check last digit. For 2 to the power 2. Oh, wait a bit. For 2 to the power 2, you will check last two digit. Okay. Okay. I don't think that you should have any doubt now. For 2 to the power 3, you should check last three digits. And for 2 to the power n, you should check last n digits. So for 2 to the power n, last n digits must be divisible by 2 to the power n. Okay. And this is the generalized formula. This is the generalized formula. Okay. So that was all from my side. Okay. In this video. And in next class, I must explain you the divisibility rule of 3, 7, and 11.